Hello everyone. Welcome back to the course of data structures using C language. This video is brought to you by Newton's group of institutions Macharla. This is Yegireddy from the Department of Computer Science and Engineering. Today in our video, let us discuss about one more sorting technique. Now let us see the second sorting technique, that is insertion sort. Insertion sort in C is simple and efficient sorting technique algorithm that creates the final sorted array one element at a time. And this technique is usually implemented when the user has very small data sets. So here we can say like this: insertion sort algorithm picks elements one by one and places it in the right position where it belongs in the sorted list of the elements. So now let us see how the insertion sort is going to work. So first what we have to do is we have to assume that the first element is already been sorted. Then we need to take the second element and store it separately in the key. Now the first two elements will get sorted. Then we need to take the third element and compare with the elements on the left of it. Similarly, what we have to do is we have to place every unsorted element and it's in its correct position. So now let us consider the same example what we have seen in the bubble sort, which consists of 5 elements, say like this: 14, 35, 28, 39 and 6. And let us use the loop, that is for loop, for I is equal to 1 to 4, that is from second element of the array to the last element of the array, that is for I is equal to 1. So here 35 is greater than 14, that is 35 will remain at its position. So here the sorted array will be the same thing: 14, 35, 28, 39 and 6. Now for I is equal to 2, 28 will move to the position after the 14 and the element 35 will move one position ahead of the current position. So if you can see here, 35 which is in the second position is being moved to the third position. So here the I value is equal to 1 and the I value becomes 2 for the 35. Then what we are doing? We are comparing 28 with the 14, which is 28 is greater. So because the left hand side elements all are smaller than 28, so we are going to place the 28 here. We are going to copy the 28 here. So in the first case, we moved 35 to this particular position. And in the second place, we are copying the 28. So here we are not exchanging nor we are swapping. So now let us see, for I is equal to 3. So here when I is equal to 3, 39 will be stored into the key value. And 39 will be compared with the second element, that is 35. And 35 is smaller than 39. So 39 will remain its same position. So there is no need of comparing 39 with all these elements. We have to compare 39 with the immediate element. Okay. So now for I is equal to 4. So when I is equal to 4, what we have to do? We have to compare 6 first with 39. 39 is greater than 6. So what we are doing? We are moving 39 to the next position. Then 6 is compared with 35. 35 is greater than 6. So 35 is moved to the next position. 6 is compared with 28. 28 is greater than 35. 6. So 28 is moved to the next position. Then 6 is compared with 14. 14 is greater than, so 14 is moved into the next position. And then to compare 6, there are no left hand side, no more elements. So we are going to copy the 6 in the last position. So this is how we are going to sort the elements in the insertion sort. Now let us consider one more example for much more better understanding of this algorithm. Suppose we need to sort the following array, say 9, 5, 1, 4 and 3. So again here we have 5 elements with index values 0, 1, 2, 3, 4 like this. So here we have to compare each element with the previous element. So first we start with index 1. So here the index 1 is 5. So we have to take the second element and store it separately in the key. So now my key becomes 5. Now I have to compare the key value with all the left hand side elements. So in this case the key is the second element and there is only one element to its left. So now let us see. So here 5 is less than 9. Condition is true, which means that 5 should be left hand side of 9. So 9 will be moved to the right side. So here initially the index value of 9 is 0. Now the index value of 9 will be moved to 1. So 9 will be, index value of 9 will be moved to 1. And here we don't have no more elements on the left. So directly we replace the value of the key at the position 0. So after the first iteration, the output will be 5, 9, 1, 4, 3. So here after the first iteration, the first two elements will be in the sorted order. So if you can see 5 and 9 are in the sorted order after the first iteration. Now the index value is 2. The index 2 element is 1. So we have to take the third element and store it separately in the key. So now my key becomes 1. Now again, I have to compare the key with all the left hand side elements. But here, instead of comparing the key with all the left hand side elements, starting with the left, I am going to compare with the immediate element. So 1 first will be compared with the 9. So we follow the same procedure, that is 1 is being compared with 9. Now here in this case, 1 is less than 9. Condition is true. So when the condition is true, we have to move the element towards the right. So the index of 9 is moved to the index of 2. So now the output will be 5, 9, 9, 4, 3. So here we are just copying 9 to the next index. So now again the key must be compared with 5. So here 1 is less than 5. The condition is true. So we have to move the element 5 towards the right. So the index of 5 will be moved to one position towards the right. So now the output will be 5, 5, 9, 4, 3. So no more elements to the left. So directly what we are doing, we are replacing the value of the key at the index position 0. So after the second iteration, the output will be 1, 5, 9, 4, 3. So after the second iteration, if you can see, the first 3 elements are in the sorted order. Now the index value is 3. So when the index value is 3, that is the index third element is 4. So we have to take the fourth element and store it separately in the key. So now my key becomes 4. Now again, I need to compare key with all the left hand side elements. So first we have to compare with the third element, that is with the immediate element of the key. So once again, the same procedure, 4 is compared with 9. 4 less than 9, the condition is true. So we have to move the element 9 towards the right. So the index of the 9 is moved to the next index. So now the output will be 15993. Now again the key must be compared with the 5. So 4 less than 5, again the condition is true. So we have to move the element 5 towards the right. So the 5 is moved to index 2. So now again the output will be 15593. So now again the key must be compared with the next element, that is 1. So 4 less than 1, the condition is false. So now no need to change the element. So we have to copy the key value at this particular location 1. Okay. So our output will be 1, 4, 5, 9 and 3. Understood? So now the index value is 4. Okay. The index value 4 means the fourth element is what? The 3. That is the fifth element is 3. So we have to take the fifth element and store it separately in the key. So now my key becomes 3. Now again the same story repeats. We need to compare the key with all the left hand side elements. So first we have to compare the key with the fourth element, that is with the immediate element of the key. So 3 less than 9, the condition is true. So we have to move now 9 towards the right. So 9 is moved to the next index. So the output will be 14599. Now again we need to compare the key with the next element, that is 3 with 5. 5 less than 3, 3 less than 5, condition is true. So 5 is moved to the index value 3. And the output will be 14559. Okay. Now again we need to compare key with the 4. So here 3 less than 4, the condition is true. So 4 is moved to the index value 2. And the output will be 14459. Now again key must be compared with 1. So here 3 less than 1, condition is false. So there is no need of changing the location of the 3. So 1. So we have to copy the key value at that particular location. So at the location 1, we have to copy the output. So our final output will be 13459. So after the fourth iteration, all the 5 elements will be in the sorted order. So where we have to stop this comparison? We have to stop this comparison when j is greater than 0 and the key value is less than array of j minus 1. So the logic's iteration stops with when j value is greater than 0 and the key value is less than array of j minus 1. Now let us write the logic for the insertion sort. So for I is equal to 1, I less than, that is for the index value I is equal to 1, 2, 3, 4. For n is equal to 5. That is according to the example what we have seen just now. So for I is equal to 1, I less than n minus 1, I plus plus. So we have to perform these 4 iterations first. Then we have to store the key value. So now my key value is equal to a of I, because we have to replace the value after the completion of the iteration. That is, we have to copy the key value at that particular location. So next, we have to compare all the previous elements. So for j is equal to I and for j greater than 0, and the logic, we have to use here the logical AND. The key should be less than a of j minus 1. So if any one of the condition is false, automatically the iteration will be stopped. Here j minus minus we are using because we have to decrement the j value. That is, we are moving from right side to the left side. While comparing, we are moving from right side to the left side. So we have to compare each element. Understood? So we have to compare each element. So if the condition is true, then we have to move the current value to the right side. So here a of, if the condition becomes, if the for condition becomes true, then a of j is equal to a of j minus 1. So we are moving the value to the right side. So if the condition for this particular loop is completed, then at that particular position, we have to place the key value. So a of I is equal to key. So the key value will be stored into that particular location. So this is the simple logic what we are going to use in the insertion sort. And here you need to understand there is no exchange or swapping. Just what we are doing, we are comparing with the previous elements. And once when the condition is false, we are inserting the element at that particular desired location. Now, let us see the time complexity. Worst case complexity is order of n square. Suppose if an array is in the ascending order and we want to sort it into descending order. In this case, the worst case complexity occurs. So each element has to compare with each element of the other elements. So for every nth element, n minus 1 comparisons are made. So thus the total number of comparisons, which is equal to n into n minus 1 minus n square. Now coming to the best case complexity, it is order of n. So when the array is already sorted, the output loop runs with n number of times, whereas the inner loop does not run at all. So there is only n number of comparisons, thus the complexity is linear. Now coming to the average case complexity, which is order of n square. So here this case occurs when the elements of the array are just jumbled order, neither ascending nor descending. Now coming to the space complexity. Space complexity is order of 1 because an extra variable, that is key, is used. Now coming to the insertion sort applications. So here the insertion sort is used when the array has a small number of elements and there are only few elements left to be sorted. So that's all for now. If you like this video, please subscribe to my channel and press the bell icon for the latest notifications. Thank you one and all.